Okay. I am going to utilize what's in the textbook just because otherwise I'm writing out word problems. Okay? So if you wouldn't mind getting with me on page 198, we are going to utilize that one, example 1. I'll have more examples for you over the next couple days, but for now we're going to use this one. And a graphic artist is designing a poster that consists of a rectangular print. So here's the print. It's going to be a picture of Carter. I'm going to draw him. He's going to wave everybody. Hi. There's Carter with his other hand's on his hip. He's kind of in his pocket. With an orange in his hand. Okay. A graphic artist is designing a poster that consists of a regular print, make his leg the same length as the other one, with a uniform border. So you guys have seen in the picture stores, they call this a mat, right? You guys probably have your school pictures or your sports pictures or whatever hung on walls that look just like this. Excuse me. The print itself, so that's the picture within, is to be twice as tall as it is wide. So if its width is that, and its height is double that, I think that's a pretty fair representation of what the book says. And the border itself is 3 inches from here to here. 3 inches from here to here. Right? If the overall area of the poster is 680 inches squared, then find the dimensions of the print. Okay, so let me just break this down really quick. The picture itself, oh my gosh, also known as the print, looks like this. 2W multiplied by W. Would you agree with me that that describes this and that? All right. When I add the 3 and 3 to the overall length, so the poster with the border, I get 2W plus 3 and 3, which is 6. Right? And right to left, when I add the width plus 3, I get 6. Right? Okay. Awesome. So I'm pretty much on step 2 with them. All right. Step 3 they've shared with us is that the area of the poster itself, that's this, is equal to, according to what they said, is equal to, 680. How do I know that? That was like the second, the last sentence. So I know these dimensions equal 680 when multiplied together, according to the story problem. And if I find out what W is and plug it in here, I'm able to answer what the area of the print itself is. Okay, I'm able to do that because I'll have that data. But until I find out what W is, I'm not able to do that. So I'm going to go ahead and start working this polynomial equation that's already factored for me, basically, because that's how we found out what the width was and what the length was. So one thing I'm going to show you is that if you can factor this further, do it. Like this, if I pull a 2 out of here, I make it 2 multiplied by w plus 3 and w plus 6. All of that equals 680. Are you guys with me so far? I know this is a little bit different than what we learned yesterday. Now, really quick, you know that 2 that I just pulled out? This is like saying 2 times this equals that. Or you might even think of it as like an old little early on equation. 6 times x times y equals 36. Okay? I could divide this 6 out here, and that gives me this xy equals 6 and whatever. We're not going to solve that further because we would have an answer of 1 and 6 or 2 and 3, negative and positive. But what that leads me to try and show you is that if you divide out this 2 from here and here, I have in effect shrunk down this equation so that it's now only w plus 3, because these 2's canceled, w plus 6 equals half of 680, which is 340. Okay? We're still not done. Remember how we have to zero out? Well, before we can zero out anything, we have to FOIL this, bring this over, refactor it, and solve for 0. Which is going to look like this. W squared plus 9w, that's 6w and 3w, plus 18, and I'm just going to subtract the 340, equals 0. So I've FOILed this out, subtracted over my 340. Now when I combine these, and you could easily look up the numbers in the book, but I'll do it really quick. W squared added to 9w minus whatever the difference of 340 and 18 is, which is 322, equals 0. Holy cow. Anybody want to factor that mess? This is why calculators come in handy. So, factors of 322, negative, that have a sum of 9, positive, is what we're looking for. And you could do that method but you don't really need to because this coefficient is that. And the book will show you it's negative 14 and positive 23. Okay. Solve for 0. W minus 14 is 0, so W is 14. Or W plus 23 is 0, so W is negative 23. Which of these two numbers can we throw out? For sure. Yep. No negative size is possible. Okay? 14 is correct for W. That makes sense to me. So if 14 is W, what's the length? If 14 is W, 28. So W is 14, length has to be 28 because it's double. And the question asks for the area, right? No, it just asks for the dimensions. Okay. But if it asks for the area, you could say it anyway. You could. Okay? Don't ever utilize a negative size. It doesn't make any sense. Or negative minutes or negative weight. Things like that just do not make any sense at all. Okay? This one is probably the middle of the road in difficulty. I actually want to go back and do one that's kind of easy. And I'm going to write it out because I don't have it here in the book. The sum of the squares of two consecutive even numbers is 100. What are the numbers? Okay, this is going to be early on in the assignment. You're going to have something like this. So first of all, give me two things that would represent two consecutive even numbers. X and x plus 2. How will I represent the sum of their squares? So here's sum, right? That's that one's square. That's that one's square. The sum of the squares of two consecutive evens is 100. Solving it from here, we're going to multiply it out, subtract over my 100, factor it, and solve for 0. So x times x, that's easy, x squared. You could break this out and FOIL it, but I'm telling you right now, look at me. The answer to this is not x squared plus 4. If you give me x squared plus 4, that means you have not O or I, your FOIL. Or you're not using the little pattern, which is a squared plus double AB plus b squared, which is the pattern I have memorized. A squared, twice the product of that, which makes it 4x. All of that, I suppose I could have gone a little quicker. 2x squared plus 4x plus 4 minus 100. So I just really quick zeroed that out. Okay, 2x squared plus 4x minus 96. Any greatest common factor action? 2. Okay. 2 multiplied by x squared plus 2x minus 48 is 0. Remember how I showed you guys a minute ago that we can divide out something that's being multiplied? Well, I factored it first and then I divided it out. Well, I'm going to divide that 2 out here. X squared plus 2x minus 48 equals 0. I know it kind of seems like I just created a magic trick, but the other way of looking at it, if you ignore the 2 until after you've factored this with your positive 8 and negative 6, 2 would be part of the factor set, and 2 does not equal 0 anyway, ever. So by dividing it out here, mentally it's gone. So anyways, x plus 8, x minus 6. And again, if I didn't do this, then that would mean 2 would still be a part of it. And solving all three of these for 0, 2 equals 0 is never true, which is why it is completely fine for me to divide that out. But x plus 8 equals 0, x minus 6 equals 0. All right. So x can equal negative 8. And x can equal positive 6. Let's use that to answer the question. What are the two consecutive even numbers? So if I start with a negative 8, what would come next? Negative 8 and negative 6. Yep, that's one pair. And how about this one? If I start with a 6, what do I have? 6 and 8. So be careful that if there are two pairs of solutions that satisfy what they're giving you, that you work those things.